This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data with Gen AI. Okay, in the previous session we were going through with a practical onto the diagram language model, and the language model is going to work onto the two letters. Like if we know one letter, then it will be able to predict the next one. Okay, so with respect to this particular example, what we have done, we were having a particular file named .txt. Okay, and we read this particular file, and then we try to calculate min and max. Like the minimum length of a particular word is 2 and maximum length of a particular word is 15. What is the content of this name.txt? Like it is having the names like Emma, Olivia, Eva. Okay, these are the names in this particular file, and our agenda is to predict the new names based upon a given letter. Okay, that will not be the part of this particular names.txt. Okay, so that is the agenda, and if like we are able to understand it, then we will be able to understand the functionality of Gen AI, like how Gen AI is working. Basically we are providing certain data, and based upon that particular data it is able to provide the outcome which is stored somewhere in its you can say stack, and based upon its analysis what it is going to perform on top of the data or input that you provide, it is able to provide the outcome. So that's what like we are willing to get with the help of this names.txt, and this is the main agenda. uh, so what we have done in previous sessions, so we read this particular file, then as this is the diagram language model, based upon the given letter it will be able to predict the next one. So the names what we were having, we have splitted those particular names into letters. Like if say if we have taken top five words, Emma, Olivia, so it has splitted those particular words into letters. Then we moved with by adding the starting and ending letter as well. So S is the starting letter with this particular name, and E is the ending letter. So starting and ending, that is perfectly fine. Now our agenda is to like if we are providing E, then M will be the next letter. So what we have done, we have created two lists. One is the original list, that is the CHS one, and second one will start from the index one. Okay, so we will be having two lists, and then we iterate it with this particular list, and what we got, like S is the starting letter. If S is the starting one, then E is the the next one, the most likely letter after S is E. And if E is provided, M is the most likely letter. If M is provided, M is the most likely letter. This is with respect to the data or names what we are having. In the same fashion it is done with Olivia. Okay, so we are having the combination of letters. Like if A is there, then E is the most likely letter, or it will be the end of a particular word. Okay, so this is what we got with the help of this. Then we moved further by adding by counting those particular combinations. So if we have taken five words, and if we applied the count, so em is coming one time, is coming one time, ma is coming one time. So with the help of this, and a and e, uh like A is the A is most likely to be the last letter of a particular word, what we got from this particular combination. So the agenda, what we are willing to calculate over here, guys, if we are having the count of a particular combination, so with the help of that, we can say, we can say if we are having a, let me increase the font. Okay, so if we are having this particular combination, a is there and s is the most likely letter, and its count is say 15,000 or 14,000, say 14,000 count is there. We are having another combination that is a and m, and its count is say 12,000. We are having another combination a and say z, and its count is only say 087 or 87, say. Okay, so what we are getting with the help of this, that s is the most likely letter which will come after a. If like I'm typing a, then s will be the most likely letter. And how we are able to get it? Because its count is more based upon the given content. Like we are having almost say 32,000 names, so out of these 32,000 name, we are having this particular, you can say, combination. This combination is repeating multiple time, so this is the most likely letter. It is something like we are having certain training data, and based upon the training data, we are training our model, and once the model is trained, then based upon the training data, we are predicting something. So with the help of count and all, we are able to get. So you can take it in another way, like say there is exit poll. Okay, exit poll is going on. Okay, and based upon the exit poll, what we are able to get, like one candidate is having uh, uh, high number of, you can say, votes that we got with from the exit poll. So what we are able to predict with the help of that particular result, that uh, the probability of winning candidate, this particular candidate who is performing good in the exit poll, will be more. The probability of winning will be more for this particular candidate. So the same fashion, in the same fashion, we are counting the repetition of words, and the count, the more count is defining or denoting that over here, say I and a, this combination is there, so a is the most likely letter after I. So what we got from this particular count? Okay, so we have counted the repetition, then we gone through with tensors. Okay, so inside the deep learning, we are working with the tensors. So if like we are having a tensor of 3 comma 5, so it will provide floating point numbers which are having 3 rows and 5 columns. That is, these are nothing but tensors. Or what we can say, tensor is the combination of matrix. Okay, so we got this. Then these are the floating point numbers, and if we want to have these numbers as integer, so what we can do, tors dot zeros 3 comma 5 and data type equal to tors dot int 32. So we can change the data type, and now the data type has been changed. At this moment, 0 dot is coming, 0 decimal is coming, but over here 0 is coming independently. So we can create the tensor. Now over here, if we want to replace any item in the given tensor, so n is the tensor what we have defined. Okay, so in this, like if I'm going to replace n 1 comma 3, so this is denoting, say, first row, this is zeroth row, this is first row, and this is the second row. 1 comma 3, first row and third column, 0 1 2 and 3, this is the third column. So, and we have given the value 3, so it has been replaced by 10. So earlier we were having 0 over here, now it has been replaced with 10. So why we have done this? Because whatever we will get, whatever we will get, the count, whatever count we will get over here, so that count will be replaced in this particular tensor. We will create a tensor, and in that particular tensor we will be replacing with the count. That's why, like, we have gone through with this particular simple aspects. Then what we have done, like if we have taken this particular, if we have taken 5 words, so, and if these particular 5 words are joined together, then we got this particular, you can say, complete letter, and it is having Emma, Olivia, Eva, Isabella. Okay, so all the names have been joined. And why we have done this, why we have joined these particular names? Because if we are having a particular data, okay, if we are having certain tokens, if we are having uh, all the tokens, and by replacing the repetition, we will have the vocabulary. Okay, so we are having names, almost 32,000 names are there. Okay, 32,000 names are there, and the names are, say, Emma, okay, Olivia, okay, Eva. So these are the names. Say, we have the names are given in this particular way. Now, if we combine all of these particular names and remove the repetitions, then how many letters we will have in total? How many letters we will have? Try to. There are, like, all the combinations. Say A to Z, all the letters are there. So, what will be the count? 26, because only 26 letters are there in English language, right? Guys, it is fine. How the vocabulary is calculated over here? Guys, are you able to hear me? Are you
Yeah,
with
so
me?
yeah, you are audible.
Okay, so I was saying, if we join all the words, all the names together, then what we will get? We will get the dictionary. Oh, sorry, we will get the vocabulary. Okay, and the size of vocabulary, it will be 26. Okay, so just have a look over here. What I have done, I have taken all the words. Okay, I have joined. You can over here, say, if I'm joining 5 words, then it has given me this. Okay, and if I'm going to convert it into set is going to remove the repetitions. So over here A is coming, you can say, single time. Okay, over here it might be possible A is there, A is there, A is there. Okay, again a is there, so a is repeating. But if I'm converting it into set, then all the repetition will be removed, and this is the functionality of a set. Okay, in the Python language, set is removing the repetitions. Set is providing you the unique values. So if we are having a particular list uh, like this, 26 comma 26, 25, 28, then again 26, then 29, then 30. Okay, and if we convert it into set, so what we will get? We will get uh, 25, 26, and 28, 29, and 30. Okay, so say over here 26 was repeating three times, so we got the single value, the repetition has been removed, and we got the unique values. So in the same fashion, what I have done, I have applied, I have converted, after joining I have converted into set, and once I have converted into set, it has given me a to z, like these are the 26 values it has given us, 26 letters it has given. So this is nothing but the vocab size for my project, vocabulary size. We have seen the GPT-3 model, GPT-3 model. Inside the GPT-3, the vocab size is what? What is the vocab size? What is the vocab size for GPT-3? Hmm? Guys, what is the vocab size for GPT-3?
Sir, it's 12288.
That is the dimension. Vocab size is 5257. 50,000, almost 50,000 you can say. And embedding size or dimension basically, that is 12288. Okay, so over here with respect to our model, this diagram model, vocab size is 26 letters, and what is the embedding size? Embedding size is, okay, that can be decided, like it can be one or two. Okay, we will decide this. There's not an issue. Embedding size we will decide. And what is the meaning of this embedding size? It is providing a way, like how many floating point numbers a particular token can have. How many floating point numbers a token can have, that is decided by this particular embedding size. Let me show you the presentation. Okay, so over here we have seen this particular stuff and we have gone through with this particular diagram, and uh, embedding matrix, that is like if we are having 50,257, these are the total tokens in GPT-3. We are talking about GPT-3 over here. If we are having 50,257, these are the total tokens, and 12288, that is the embedding size. If we multiply it, so we will be getting the embedding matrix. And say if we are having this particular input, Gen AI is changing the, and we are trying to predict the next word over here. So Gen, that is the one token, AI is the another token, is the another token changing, and the like we have converted into tokens, and these are the floating point numbers with respect to each and every token. So it can be for the bipolar, like we will move with say two tokens, two embedding size, three embedding size, we will see it with practical. Okay, like if we are having two embedding size or three embedding size, what will be the impact onto the outcome, that we will see. But over here what we are able to see, 12288 is the embedding size for the GPT-3, and 50,257 are the total number of tokens. And you can check it over here. Total tokens in GPT-3 model. Vocab size 5257, right? And we have seen like how we can have 175 billion parameters if in GPT-3 model. We have seen this particular stuff. Okay, moving further. So we are having 26 letters in English language, and as we are moving with the bigram model, so this is the vocab size for us. But there is an issue with this particular with these particular letters. Okay, because what we have seen, we are having starting and ending character as well. So we will add starting and ending character as well. So over here, like starting and ending character has been added. Now over here what we have done, we have indexed these particular letters. Okay, and A is onto the 0th index, B is onto the first index, like that is string to index and index to string. Over here what we are having in enumerate function, and enumerate function, what it will do, it will add the index. So we are having 0 1 2 3 and 25, up to 25 we are having total characters. It means like 26 the total letters are there. And over here we have enumerate has given us in index to string, so we have converted into string to index. So we got A is onto the 0th index, or we got as a it as a dictionary. Okay, we got it as a dictionary. Now we have added the starting and ending letter as well in this particular string to index dictionary. We have added S onto the 26th and E onto the 27 index, and we are able to see this. Okay, that is perfectly fine. Now we have created a tensor with 28 comma 28 size, and its data type is integer, that we have seen. And now what we will do, we will uh, we will move these particular letters in this particular, you can say tensor. So over here, like what we are having the simple code. We have taken the 5 letters, top 5 words, and we have added the starting and ending character. Then we have converted into list. The stuff what we have seen over here. Okay, this particular stuff what we have seen over here, same has been applied. Now what we will do, we will apply I of x, that is that will be, you can say, over here the ch1 will move, and into the ix2 the string to index ch2 will be move, and then we will make it ix and ix1 and ix2 equal to like plus equal to 1, like we will keep on adding, and it will iterate with respect to this particular, you can say, list, and we will be able to get the outcome. Okay, so the same code what we have used in over here, the same code. Now it has been given with the tensors, and we got this particular tensor, we have calculated it for the 5 letters, 5 words. Now it has been calculated for the complete words inside the given names.txt, so these are the total words, and once we have done the calculation for all the words in the given names.txt, so we got this particular count. Okay, so over here, like what is the meaning of this? It has been discussed in previous session as well. Okay, so this is nothing but like A B C D up to E, ending character E, and A B C. So in the same fashion, like we will be having say 0 1 2 over here, like we are able to see the count of A to G. Okay, so in this particular given word .txt, sorry, names.txt, if we if we split the names, and A after A is coming 556 times, and B A is coming after B 542 times, and D is coming after A, that is 1042 times, that is the count, so we have calculated the count, like say over here, if I'm talking about this A B C D E F G H I J K L M N N. Okay, so N is the most likely letter after A. If I'm typing A with the help of this particular count, what I got, A is the most likely letter. Its count is more over here, because the count is more. So what we will do, we will try to see, and we will try to plot it, and then we will try to visualize it, what is happening. So in order to plot this, I'm having this sample code, and I will paste it over here and just run it. What I have done, I have imported the matplotlib. What is happening? ITOS is not defined. Okay, let me define this. Let me define it and then I will explain it. Huh? Now it is coming perfectly. Huh? 556 AA BB 56 542 556. Yes. Okay. So what I have done over here, I have plotted it. The count what I was getting with the help of this. Say A is coming after A, that is 556 time, and B is coming after A, that is 542 times. So uh, I have calculated the count, and this is like the simple code in order to calculate the count, and we have done this calculation over here as well, like I have explained in previous session. You can go through with the recordings of previous session. So the count I got. Now I try to plot this particular count. So in order to plot this, what I have taken, I have imported the matplotlib library, and the figure size of this one, and then the plot.im show, and and the color, like what I have chosen, the blue color is chosen, and for I in raised 28, for J in raised 28. So this is denoting like the x and y axis, and then uh, from x-axis, like the values are like this one, and from y-axis I have taken the values like this. So in order to plot it with respect to the y-axis, so i I to s, index to string, need to be calculated. So I have done the calculation over here, and how it has been done, like for s comma I, string to index, in stoi, this was the string to index uh, dictionary what I'm having, and dot items, I have taken the items from this, and then from these item I have taken I comma s. So if like it has given like this, so I have taken it like this. Okay, I have taken like this. So string to index, index to string, that is the stuff what I have done over here. Then it has been plotted simple, like if you, there is no need to, you can say, go with the syntax and all. If you type it like how to plot a particular matrix onto with the help of matplotlib, the similar code you will get, and then you can plot it. So once you plot it, the main thing what you need to understand over here the count, the dark count is denoting like it is coming multiple times. If the values are in light color, so that is coming, you can say small number of time, less number of times. So 556, 542, 4470, and over here I think this is 5000 something, because of the color only we are not. This is the ending character, and if like I'm typing a, then ending character is the most likely letter. Okay, and most likely letter what we got with the help of this 6645, because ending character is coming multiple times over here. Okay, in the same fashion, like what we are having, like BA BB, okay, and CA DA, okay, A after, over here it is like this, A is coming after A is coming after B, A is coming after C, A is coming after D, okay, A is coming
Hello. Is this program only in my system or in everyone's?
I think I got disconnected from the meeting.
Yes. Technical issues.
Hello, guys, are you able to hear me? I don't know, like, what happened, and it was disconnected. Guys, are you able to hear me? Vijay, Gurmeet,
Yes, sir.
Tejas.
Yes,
Yes,
sir,
sir.
we are able to hear you.
Yes, sir.
Okay. Uh, so I was saying that the starting character S, starting string S, it will be having zero probability. What I can
So
say,
your
zero
screen is
chance.
not visible.
Okay, okay,
So
sorry.
screen is not visible.
Okay, okay. Let me share. And if like you are not able to see, or if you are not able to hear my voice, you can text me on my mobile, or you can call me on my mobile. Huh? Okay. I don't know, like, what has happened, and the session was disconnected for me. Huh? But I was keep on speaking. Huh? Okay. So what we got, the count for each and every combination. Okay, we have plotted that particular count, and after plotting this particular count, what we are able to see that like after A is coming, and it is having count 556. Huh? But at the end, what we are able to see towards the end, what we are able to see, uh, the A, and if A is the character, and the starting string S is having zero count. Huh? What is the meaning of this? Say if I'm having starting of a particular string, if this is the starting of a particular string, that is the normal way, and if I'm having a particular letter, so after this the starting string will not come, it will never come, right? After a particular letter, starting string will not come. That's what we have seen with our examples. Okay, over here, over here, over here, S is the starting, and then we are having the letters. Okay, and if I'm having a particular letter, so after that starting string will not come. That this is with each and every word. Okay, because of that only we are having this particular count zero. Like if A is there, the starting string will not come, because the word already, the word has been started already. Yeah. B, if B is the letter, starting string will not come. Okay. So what we are able to see, this particular row, this particular column, that is having 0 count, and in the same fashion we are having 0 for the ending string as well. Okay. So if something is ending, if we are having ending string, then no any letter will come after the ending string. So because of that only the count is 0 for the letters. Like if we are having this E, that is the ending string we are having, this is the ending string, and after ending string A is having 0 count. In the same fashion B is having 0 count, C is having 0 count. So C is having 0 count. Okay. So that is perfectly fine. So what we are able to get with the help of these particular this particular row and column, that if the count is 0, so there is no need to keep this particular data. We can remove it. Like we are having uh, 28 cross 28 dimension at this moment, and if we are able to optimize it, and this particular 0 count is not making any sense in row and in column as well. Okay. So if we are able to remove it, then that will optimize our code, the performance of the code will improve. Okay. That's what we need to do, and definitely it will be going to optimize our code. So we have taken S is the starting string, S is the starting string, and E is the ending string. E ending string, starting string, and E is the ending string. Okay. So what we will do, we will try to optimize it, optimize the code. Optimize the code, and how we will be able to optimize, just replace starting and ending string with dot. Okay. So instead of this, what we are going to do, so we are having this particular piece of code, this piece of code is there, and over here what we have done, we have added starting and ending character. So instead of this, what we will do, we will add dot instead of starting and ending string. Okay. And let me try to run it. uh, what is the issue? Okay, stoi. Yeah. We need to add dot in stoi as well. So this is I'm pasting the code what we have typed. So instead of this, what we will do, we will just add a particular dot, and it will act as a starting and ending character. Okay, like if dot is there, we will be able to see, if dot is there in starting, then we will be able to see this is the starting, and if dot is there at the end, so we will be able to see this is the ending of the you can say a particular letter, and we will what we will do, so we will start it with 0, and we will start this stoi with first index, okay, and let me try to print stoi, okay. Okay, a is at 0, and dot it is at the 0th index, you can keep it as it is as well, okay, but like just to give you a little bit change, so what I have done, I have started the a from the first index, and at the end, at the 0th index, I have added the dot, okay, that is perfectly fine. I'm having stoi, and in stoi I'm having the dot as well, and let me try to add it, okay, that is perfectly fine, and the same count of 556 is there, okay, 556, and this count has been increased, we'll see, okay, 4972, 4972, we'll try to plot it, and then we will see what has happened, okay. Okay, so we are able to get the count for all the 26 letters A, B, C, D, E, F, G. So we will be having the 27 letters. In fact, and dot is also there. Okay, so we are having this one. Now we will try to plot it. We will try to plot this. So for the plotting, like we will be using the boilerplate code, and this one is the same what we have seen. Four nine five two. This is the same code, the same piece of code what we have executed over here. Okay, this is the same piece of code. Okay, so the now it is a little bit more optimized, because we have removed the unwanted stuff from this particular code, like dimension has been reduced, and like if a particular you can say matrix size or tensor size is reduced, definitely it will boost your performance, so the performance will be boosted, now what we will do, now what we are going to do, say this is n, and if I'm going to have n0, n0, you need to pay attention over here, this is n0, n0, that is like the first row I'm having, okay, and what is the shape for this n0 dot shape, okay, 28, it should be 26, okay, I2S 27, it should be 27, just a minute, stoi I2S is calculated over here. I need to do the calculation for I2S over here as well, It should be 27, because like we have added the dot. Mm, hmm. Let me restart the kernel. I'm not getting the correct count. It should be 27, because like the starting and ending string has been removed and it has been replaced with dot. So dimension should be 27. Still 28. What we have done, the Z is removed. This particular piece is also removed. That is perfectly fine. And dot shape 28, 28. It is coming the same. This zero, uh, okay, 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 okay. So, so what we need to do, we need to define a tensor. Over here, that is my mistake, guys. Okay, we have defined a tensor 28 cross 28. Over here, we have defined this particular tensor. Okay, so this particular tensor was defined. Okay, this tensor was defined, and in this particular tensor we are moving the count, what we are counting from this particular for loop. So this is of 28 cross 28 size. Because of that only the shape is coming 28 cross 28. So what I need to do, I need to define a tensor over here once again, and before this calculation, and it will be 27 cross 27, and then I will move these particular values into this particular tensor, and the shape will be changed at that moment. Okay, we have, let me try to explain over here. So we have defined a tensor that was of uh, torch dot tensor. Okay, and we have defined it like this at 28 comma 28. So this was defined initially, once we were having 20 vocab size 26, and we were having starting string and ending string. So 27 26 27 28, because of this, like we were having 28 cross 28 answer. But at this moment, like we need to define 27 comma 27 tensor, because the starting and ending letter has been replaced with dot. Guys, is it fine? The starting and ending letter has been replaced with dot. So vocab size, that is 26, plus this dot we will be having 27. The tensor size will be 27. So we have defined it, and now the toast dot size that is 27. Okay, so we are able to get the shape of 27, and like little bit optimization we have done. Okay, now this is the zeroth row. This is the first row basically. On to the zeroth index, this is the first row. Okay, and if we try to calculate like which is having the highest probability among this particular line, over here, if you are able to see, say we have picked this one. We have picked this one, or let me take this. We have picked this one, and that is, say, over here I'm having A, and this is A, B, C. Okay, in this fashion, D. Okay, we are having this particular count. Now if I'm saying what will come, which letter is having highest probability uh, to come after A, so how I can calculate? If I like calculate the sum of these, okay, like say sum is 10,000, and if I divide each one, say 556 by 10,000, so I will get some numbers, like say 0.32, 0.45, like this. I will be able to get or you can say the percentage, the probability percentage or the value percentage from 1 to 100. Okay, I will get the percentage contribution for each and every number, and if I got the percentage of each and every number, at that moment I can say this is the most likely letter which will come after A. Okay, like A can come, B can come, C can come. This is the most likely letter. Say after A is most likely letter, or B is most likely letter, or C. So with the help of that, I will be able to calculate the. I will be able to say that this is the most likely letter. So how we can calculate that? So this is the size of this particular tensor. Now what I will do, I will define a particular variable p, and I will take n dot 0. This is the first row I have taken. I have taken first row and I have converted into float. So it will be converted into float, and what I will do, p equal to p divided by p dot sum. And so it will be like this. Just have a look. P equal to the same in float numbers, floating point numbers. And if I divide p equal to p divided by p dot sum, p dot sum. So, and if I calculate, if I print p, so it will come. So over here, with the help of these particular numbers, what I am able to get, this is say 4%, this is 13%, this is, I'm just trying to check the percentage. So 4410, okay, 4410, that is having the 13%, uh, that is having 13% contribution. Okay, and this is say most likely letter after A. Okay, after A, after A, after A, that is, you can say, okay, this is 0. Like we have plotted this one, 0, and like after 0 it might be the starting. Okay, after that is dot, dot or 0, whatever. Okay, so A, B, C, D. Okay, so A after A, this is like this. Let me try to explain it. Okay, so we are having what is that, the zeroth index? Zeroth index, I think it is dot. Dot is there onto the zeroth index. Then A is there. Then B is there. B is there. Okay, and over here we are having dot that is onto the zeroth index. A, B. Okay, and zeroth index. Okay, let me take. Okay, so it is like after, if it is starting or ending, then dot after dot, that will be the zeroth probability. Yeah, that is the count zero is there. Then after dot, like it might be the starting, or it is denoting A can be the starting letter. A can be the starting letter, and let me take n dot one. Let me take the first row from this particular given, you can say, records. Okay, if I'm taking the first row, it is coming like this. At this moment I have taken the first one, and it is coming like this. Okay, so what it is saying, what we are able to get this from this, like A, and if dot is there, if dot is there, then A can be the most likely letter. Like it can be the starting of a particular uh, letter. Dot after dot, A is coming, and after A dot is coming. After A dot is coming, that we are able to get from this. Say if I'm giving dot, so dot after dot, that is not having any probability, the count is zero. And if dot is there, it might be the starting of a particular letter, word. So if dot is there, then A is the having the highest probability. That's what we are able to get with this particular count. And if A is there, then the dot is coming, that is 6640. So it is having the highest probability that after A is the last letter of a particular word. What we are able to get from these particular numbers. That's what we are able to see over here. The this particular first number at this moment, we have taken the first index, and over here it is having the 19% probability. The second one is having 1%, and another number, this is having the 16% probability, and so on. So we are able to get the contribution of each and every number, each and every count. Okay, and this count is denoting that after a particular letter, which one is most likely to come. After a particular letter, which one is most likely to come. So that's what we are able to get from this particular number. Dot after dot, that is zero count. A, like if A is there, then the dot count is 6640. So this is the most likely letter at this moment. uh, so with the help of this, we are able to get the count and all. Now p dot sum. P dot sum. So we will be having the sum for what will be the sum for P? What will be the sum of P? Guys, what will be the sum for P? This is simple maths. So the sum for P will be 1, right? If we have given certain number, and if we have divided each number by the sum of the total numbers, then we will be getting the percentage of each number. And if we sum all of these particular numbers, then we will be getting the outcome as 1. Okay, so p dot sum equal to 1. Now what I'm having, torch dot multimodal, multinominal, sorry, torch dot multinominal. And in this particular multinominal, I will pass this particular p, and I just num samples. I just want to have num samples equal to say 1. I don't want to have replacement equal to true dot items. Source dot multinominal. Multinominal is there. Let me print and then I will explain. Okay, so what is the meaning of this? So if I'm passing this particular p, okay, if I'm passing this particular p, and based upon this given, based upon these particular given values, if I need to find out, uh, if I need to find out like which one is most likely to come, which one is most likely to come, then multinomial function is there inside the torch library. So I can pass this particular p, and say if I want to have number samples 1, I can have multiple samples as well. Okay, if I want to have one sample replacement, like replacement true, so it can, by default it is, you can say false, you can set it to true, like it will be going to replace the new one. Okay, so you can set replacement equal to true, and you will be able to get a particular number. So this will be the next, you can say, this is the most likely letter if you are passing a particular sequence uh, into the multinomial function. So this is the sequence p what I have passed, and it is able to predict that this is most likely letter, or this is most likely from this particular given list, or the values that you are providing. So we are providing P as an input, and based upon this, like, we are trying to try to find out one sample. Okay. Now over here, one another variable is there, g dot torch dot generator, and I can say manual seed I can give over here, and I can give a value like any value I can give. Over here at this moment, if on each and every iteration, it is providing me the different index. So say zeroth index was given 8 index. If I execute it, 8 is given. If I'm going to execute, the zeroth is given. If I'm execute it once again, the 14th is given. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it is giving me, obvious, it is giving me the values which are having the highest percentage. 14 is given, sometimes it is giving 18, 18, 16, 17, 18. It is having the less percentage, but it is given. So in each and every iteration, it is providing me the different value. But if I can provide, if I want to get the unique value at each and every iteration, so I can set this seed over here, generator equal to g. Okay, so I have given a value of seed over here, and it will fix the outcome. Generator dot manual seed. Okay, so at each and every iteration, it is not taking a replacement. Manual seed, it is not picking. Now, like, okay, now it is providing me the zeroth value because this is having the highest count, 19, 19%. So I can set the generator as well, and generator is going to fix the value. And if you want the random output at each and every go, so you can remove this generator g from here. Okay, so let me try to explain, then we will proceed. So what we have done so far, we were having names.txt. Names.txt was there, and onto the name.txt we have converted into words, and then we have split it into letters, because we are working with the bigram model. Bigram model is working onto the single letter. If you are providing a, then it will be able to predict the next likely character. Likely character. Okay, so we have splitted into letters, then we have calculated the combination of letters. By combination of letters was taken with the help of list, with the help of list indexing. Okay, so like one list is starting from the zeroth index and another one is starting from the first index, so we got the index. Okay, then combination is fine, then calculated the count for combination, of combination. Okay, calculated the count for combination, then created a tensor and replaced these count. Replace tensor with count. So we have done this. Then we optimize the tensor. Optimize the tensor. So optimize tensor, so it is of 20 cross 20 20 cross 27. Previously it was 28 cross 28. Okay, so this was the tensor, and we have optimized replace the tensor with the with the count, and we were having 28 cross 27. Then we optimized the tensor. Okay, then after optimizing the tensor, what we have done, we have taken the first row, calculate the percentage of each letter, and with multinomial, sorry, multinomial function, we predicted which one is most likely to come. Okay, most likely to come. Okay, so uh, we have done these many steps so far, and over here, like based upon the single row, we are able to find that this is the most likely letter. Okay, but we are having the tensor of 20 cross 27, 20 cross 27. This was is the tensor size what we are having, and we have done the calculation for 1 cross 27 at this moment. 1 cross 27, like we have taken the row, and all 27 items were taken, and based upon that, what we are able to see that like 0, 0 is having the most likely, you can say, character. Okay, now we have replaced this, we have removed the G. Okay, generator G, and let me set it to true, and at this moment, like, we will be able to get replacement equal to true, and then close this. Okay, multinomial P replacement equal to true dot item. Okay, so with the help of this, like from this given tensor 1 cross 27, like we are able to get that second index is the most likely letter. If I'm giving a, 19 is there. If I'm calculating it once again, 0th is there. If I'm executing once again, the 14th is there. So multinomial function inside the TOS library is going to provide me most likely letter from a given tensor. Okay, if I want to get, so say uh, hmm, so what I will do, uh, let me try to explain more about this. So we are having, say, G, generator G over here. I have defined generator G, and I'm having, let me take uh, hmm, let me take P over here, and torch dot P equal torch dot random. I just want to have the random numbers, and three random numbers, and based upon generator G, I'm going to use a generator G equal to G over here, and P, let me try to get it. Okay, so it has given me the these random numbers. If I am going to calculate once again, okay, so with this particular seed, uh, I will be getting, say, I got these particular tensors, three tensors I'm getting now. Now what I can do, if I want to have what this particular multi nominal function is doing, say if I'm having these particular numbers p, and let me try to toast dot multinomial, and if I want to have sample equal to say 100, replacement true, and generator equal to G. Okay, so what we are able to get with respect to this particular P, we got 100 samples. These are the, you can say, 100 sample, not 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the 100 samples. Okay, these are the 100 samples what we got with the help of this multinomial function, and it is based upon, you can say, this particular P. Okay, so what I can say over here, the multinomial function, what it is going to do, it is going to provide it is provide the number of samples. Okay, new number of samples basically. Like we are having only three values, but based upon this we are able to generate 100 values. 100 values, so you can, and these are the new values basically. These are the new values based upon this, and we have taken this particular random number, three numbers was generated with the help of generator G, and same is utilized over here. So what I want to say, multi-nominal function is utilized in order to generate the new names. Okay, over here the manual calculation is being done. We will be having the next round of calculation as well, with the help of machine learning models and all. But the multinomial function is utilized in order to you can say predict the letter, or predict the most likely letter, based upon the given indexes, based upon the given values, or even we can generate the new values based upon the given range. Okay, so three numbers were given, and based upon these three numbers we are able to generate the new samples. We have taken the new samples. Okay, so that is what we are able to get over here. Now what I will do, G dot, I will take this one. I will take this generator G. Okay, and generator G is executed. Now what I will do, I will set I of x as 0, I of equal set to 0, and let me mention while true, unless this is true, then P of n, and I will take this ix dot, I will convert it into float, and p equal to p dot sum, p divided by p dot sum, what we have calculated over here. Okay, the same stuff we are going to utilize. P equal to p dot sum, p equal to p divided by p dot sum, and I of x equal to, uh, I am going to use this particular line, dot item, toast dot multimodal samples replacement true, and generator g is also utilized. Generator equal to g, and now I will print I2OS of ix. If ix equal to 0, then break. And let me try to execute it. I will explain it. What has happened? I of x is not defined. Let me execute this one. Okay. And guys, just have a look. AIS A AIS SASORI. This is nothing but a name has been predicted by our model. Okay, our model has predicted a name over here, and this is the name, and it is not available in the given, you can say, names.txt. Okay, it is not available in names.txt. Even like what I can do, mm, in order to get it in more, you can say, good way, let me try to add certain more things over here. uh, so g, generator g, I will explain, no need to worry, and you will be able to get it. So generator g, that is fine. For items, for I in range say 5, I just want to have the 5 names, uh, and then I will set this I of x equal to 0, and I will have output, I will set output to this, and then and Mm, out dot append. Okay. Hmm. Okay. So over here, what I have done, so like up to so far, probably like you are able to get the clarity like what we are doing. Multinomial nominal function, multinomial function is utilized in order to generate the new, you can say, words, new letters. Basically multinomial function is utilized. Generator G is going to use a seed, like generator is utilized in order to set a value of G, or in order to set the value of seed, so that the outcome will not be keep on changing. This is the machine learning stuff basically. Like say if you are having certain random, if you have used random values or random numbers, okay, if you used random numbers, then uh, at each and every iteration the output will keep on changing. That is the function, that is the functionality of rand number inside the Python. Random numbers will keep on changing, but you want to like keep your outcome stable, and that will not be impacted because of the change. So you can set the seed. So seed is going to take the same kind of input and provide the same output at each and every go. So seed is set, and then what we have done, uh, we have taken like with the help of the while loop, like until unless it is true. So p equal to n of ix. So n is our n is this particular complete tensor, that is of 20 cross 27, and ix is say 1 0 1 2 3 4 5. Okay, so p of n ix, and I have converted it into float. So if I'm taking 0, so p of n 0, that is float, and then the same stuff what I have done over here. Like I have calculated it float, then I have taken p divided by p dot sum. So the output I will got in percentage of each and every row. Okay, uh, percentage with respect to each and every row, and with from this I will be able to get a particular number. Like if a is there, then next letter is a, that is having the most likely, you can say, letter at this moment. So with respect to each and every row, I have calculated this particular stuff. Then I have then this particular ix, say ix is 1 over here, and this particular ix is calculated with the help of this. It is replaced with the help of this one, multinomial, and I have taken one sample. So it will provide me say 1 2 3 4 5 in this particular way. Like I will be getting the outcome, like say 14 is I got 14 now. So the 14 is got, and then print it of ix. So onto this index, so say it was 14, so print it on this particular index. What is the value? Say say 14 is there. This is stoi itos index to string. Index to string, it is this one. So sorry, this is string to index. Let me try to print over here only. itos itos index to string. So on 14, what is the value? N is there. So I got n. Okay, so in this particular way, if iox of 0, then break, like until unless it is not 0. So it will keep on iterating, and I will be keep on generating the names. So, so over here, like it was keep on generating. Once the value is 0, 0 is nothing but the ending character. So 0 is nothing but the ending character, then break is there. Probably you are able to get the functionality for the while loop. Now with the help of this particular iteration, we are able to get one name. Okay, one name is generated, but what I want to do, I want to generate the 5 name over here. So I have iterated it 5 times, and whatever the outcome I'm getting, I am keep on appending this particular out list, and then uh, then the same stuff, like if I of equal to 0, then break, and then I have printed this particular, you can say, outcome with the help of, like, say, whatever is there, with the help of join, like nothing is there and I joined it with out, so I am able to get this particular outcome, right? So with the help of let me explain over here. So with the multinomial functions, we are able to predict it, like which one is the most likely letter. So it gives us the index, it gives us the index with index we find the letter from I to S, index to string, dictionary, and index to string. We iterate it with while loop, iterate it while loop until unless the and character, or until unless index is equal to 0, because 0 index is denoting and. Okay, so this is the complete stuff what we have done with the help of this particular example. Okay, so initially we have taken a particular names.txt. Let me explain it once again. Okay, so we got in names.txt. Names.txt is converted into words. We have read it and line has been splitted. So we got the words, min and max of words. We have taken 10 words over here. Then we have calculated, we have splitted the words into letters. Okay. Then we added the starting and ending character onto the words which are converted into letters. Then we calculate the combinations, like what is most likely to come next based upon the given data. Then we count the sum of each and every combination. Okay, then we have created a tensor of 28 cross 28 size, and all the count what we got from these particular words is moved to that particular tensor. Okay, and we got the tensor in this particular way. We tried to plot this particular tensor and identified that there are one row and one column that is having 0 count for each combination, so that is not making any sense. So we have removed that particular row and column. Then the tensor is changed to 20 cross 27. Okay, then what we have done, we find out first, we have like taken the first row from the tensor, and then we divide each element by the sum of that particular row, and we are able to get the percentage of each and every element. This percentage is denoting, this value is denoting that the higher, if any letter is having, any element is having higher value, that is denoting it is the most likely letter uh, from that particular combination. Okay, then we have created a with the help of multi-nominal nomial function. With the help of multinomial function, we pass this particular p, and we find out the next, you can say, letter, which can be the most likely letter if I'm giving certain values. Okay, and I will keep on calculating each and every letter by giving this as an input, until unless I am having dot as the zero as the ending, you can say, index. So uh, I have taken n, that is the tensor, and I have taken say 0th row, first row. It will keep on changing. Okay, and based upon this particular stuff, I am going to calculate an index, and I will based upon that particular index I find out the value on that particular index from from itos dictionary. And once this particular index value is 0, then it is breaking up. Okay, so this has been, you can say, calculated for calculation, taking the 5 names. And now I'm going to calculate it. I'm going to calculate 10 names with the help of this. Now the important thing what you are able to see, isori, n dot, maja, I dot, gaha, el dot, uh, kali dot, kid dot. Okay, so these particular, although like the code is working perfectly, I'm able to get the new names, but these are not looking as a name. Okay, n is not a name, I is not a name, el is not a name. Okay, so I'm able to get the output with the help of multinomial function, and manual calculation is being done over here. But these names are not looking as names. Okay, we need to optimize it further. And in tomorrow's session, we will try to move it further, and we will further try to optimize it in order to get meaningful names. Although like we are able to get the names over here. If I'm typing say 15, and I'm able to get this, let me change the seed value over here. Okay, seed value change. So at this moment, like we got cosa, cn, jutrile, sander. Okay, Keller, Lico, Kine, Ci. Okay, these are the names. These are not present in the given names.txt. N dot, s dot, ka dot. Okay, dot is denoting the ending character. No need to worry about that. Okay, so cosa is the name, and dot is denoting the ending character, ending letter. Okay, so these names has been generated, but these are not looking like a name. So we need to further optimize it in order to get the meaningful output. Now guys, what I have observed, like you are not practicing, so try to do practice more and more. And if you are not able to understand the code, that is fine. That is that is there will not be any issue, but you need to understand the logic why we are doing this. You need to understand the logic. Code can be generated if you are having the logic. It can be generated with lots of, you can say, GenAI portals are there. Okay, you can generate it with chat gpt, grok, deepseek, Gemini. Okay, lots of portals are there, but you must have the clarity about the logic. Context should be cleared. Until unless you are not passing the correct context to the GenAI model, okay, it will not be able to predict. We will see how to create your own chatbot. We will see how to create how to create a model that will be able to write a code. We will see. We will try to make the chatbot with respect to the given data and all. Okay, so we will do it, and we will try to make a model that will be able to write the code for you. Okay, like you will pass that I want to have a Python code, PySpark code, or C code. Okay, so in order to find out the highest number, or in order to get the second highest number, so we will be able to create certain uh, uh, models, chat models. Basically we will pass our text and it will be able to provide okay, so that we will do. But you need to have the clarity about the logic. Okay, that is mandatory, and try to practice more and more. I just got the inputs, like I have given the straightforward code, and only single person has executed those particular codes into the Google Colab. So that is not accepted. Like if something is given to you, if and I have asked multiple times, and nobody has reverted onto that particular messages, so that is not accepted, guys. So try to do the practice more and more, and it is for your betterment. If you spare time, if you do the practice, you will get the clarity, right? So try to do the practice more and more, and from the logic perspective, it must be cleared, it must be cleared, and you need to have the understanding, because these particular things will be utilized. And once we are going to utilize these things, then I will correlate that we have done this particular stuff, and that we have seen in our previous sessions, and over there, from there, like this context is being utilized now. So this is mandatory to everyone to do the practice. Okay, to go through with the sessions, and try to execute the code. This is the straightforward code, but you must have the understanding that what this particular code is doing. Okay, so I tried to make these particular notes. So what we are doing with respect to this particular uh, background language model, and what I expect from all of you, that you will practice, and like if anything is there that you are not able to get, then ping me. If you have any doubt, any confusion, then you can ask. Swati, Vijay, Shivam, Gurmeet, Vikas, anything that is there in your mind, no? And we will be using, guys, like I have taken the subscription of OpenAI. Okay, and I will try to show you like how I am going to use the OpenAI key. Okay, over here, like if you are able to see, uh, like I'm having the OpenAI key, and this key is utilized, and I have taken GPT-4 nano model. Okay, and it has been utilized in order to provide you the outcome, like uh, in the same fashion the chat GPT is providing what is the capital of Japan, Tokyo. Once upon a time in a far web, it is going to predict like it is a story. Okay, so these particular things we will see in our upcoming sessions. We will be having our own chatbot. Okay, and based upon the context, based upon like if I'm saying that this particular chatbot will only be providing the output with respect to medical field, so it will provide the output with respect to the medical field only. If we are providing the prompt, if we are saying that it will provide the output with respect to the cricket game only and nothing else, so it will provide the output with respect to the cricket game and all. So we will see, we will try to do it by ourselves. and things will be more and more interesting, but you need to do the practice, bipolar and all that, bigram model and all that is good for understanding perspective. And like from the code perspective, in the upcoming sessions, once we are going to develop chatbot and all, so straightforward code is there, just we need to copy and paste. Okay, and you will be able to do, like from the code perspective, there is no major stuff, if you are having say one model, if you are able to see over here, chat gpt, so chat open ai, and you just need to change the model, temperature is given, you can change the temperature. So this is straightforward, you can say, code to initialize the chat model, okay. So you will copy and paste or you can type it, but from the code perspective, this is the stuff that you need to to write, and you need to provide a good prompt, and then you will be able to get the output, so from the code side, no major stuff is there, but from the logical perspective, you need to understand the logics, and that is very much important, so that's it for this particular session, thank you.